part of what I said was going to be on the recording actually is not going to be on this recording since I did carry the robot down with me. However, it's on the recording from last week, last Tuesday when I demonstrated the robot. I showed how to find the what COM port it is, but you can guess between 3, 4, and 5 right there. So, okay, this is the whole idea of this here is for you to play with the robot essentially. And I use the word play loosely, but that's essentially what I want you to do. There, I gave you an assignment, a particular thing to do, but I'm more interested is that you get the robot out and you write commands to it and you manipulate it and you see what it can do. There, and then of course the goal is you're supposed to pick up an object, turn it, and then put it back down again. Right there. That's all you're supposed to do. I didn't make any requirements that you move it or it has to go into a certain place. Right there. And if you want to cheat and just move the robot to a certain place, and then remember where you moved it to, and then do the experiment, that's fine. There. Or you can put it in a certain place and figure out where it's at. There. Either one. There. So, okay, the goal of this lab is to introduce you to using the robot with MATLAB. So you're going to have to use MATLAB. There. Now, there. Yeah, we moved around 3 different rooms here, and we're on our way to the 4th room. There. So I've tried multiple rooms. So this was interesting. We found a room there. Our original room was working today. Okay, there. You're required to simply pick up any object from anywhere you want on the arc, and I pointed out last time that it has to be on that particular arc that the robot arm can reach. This robot arm is somewhat limited in terms of its flexibility in terms of where it can pick things up. Originally they talked about doing a experiment where you can pick up a chess piece and move it to a certain place, and they put a chessboard on the original ones, and then they discovered that I don't know if they discovered, I think I just pointed out that the robot doesn't have any way to extend or contract, that therefore it cannot reach but only about 8 or 9 places on the chessboard. So our robot is limited in terms of where it can pick things up. So, okay. The first thing you need to do is identify the various motors and their range of motion. So if you read the lab assignment, I had you just simply draw a sketch of where each of the motors go to. This is 0 degrees, this is 180 degrees. This here is 0 degrees, this is 180. And just a simple hand-drawn sketch that you scan in, or you could do it on a computer. But you should have 6 drawings that just show where each of the 6 motors go in terms of their range of motion right there. So, again, you need to identify the various motors. And I tell you right now, I took a picture of the robot that they're actually, I took a picture of the robot and I didn't use it. I used the one from the manual that they supplied. But these are our 6 motors right here. The base that rotates our unit around, our shoulder, which moves the thing up and down right there, that moves this up and down, our elbow that moves this one up and down, our wrist that simply allows this thing to turn there. The gripper, we have 2 motors for the gripper. One is to rotate this way, and of course my camera is not on, so it doesn't pick that up. And the other one is to squeeze and pick things up right there. So they are identified by these motor numbers right there, 0 through 5. So you need to know what motor is which. So this tells you which motor is which. Each motor can move between 0 and 180 degrees, so you have to identify 0, 90, and 180 for each motor right there. And you could do that by just simply writing the code and tell it to move to 0, write down where it's at, move it to 90, write down where it's at, and move it to 180 and write down where it's at right there. And you just simply draw a simple sketch right there. So in other words, your sketch would look something like, say I'm doing the base right there. The base, here's your board like this here, here's our base, and you would just simply say 0 degrees, 90 degrees, 180, something like this, if that's what it is right there. And that's what you would turn in as part of your drawing. Maybe it should probably look a little neater than my drawing. And then the same thing with the shoulder, like this right here, you would say that this is 180 and this is 0, and you just point out what side is which, left or right side right there. Is that there? So in other words, the whole idea is that you need to know which motor goes where so you can guesstimate how you want to place the arm without going through all kinds of steps that there. So you've got to figure that your shoulder needs to be somewhere around 30 degrees, your elbow needs to be somewhere around, 50 degrees. I'm just making up numbers that there, and then you just experiment until you can pick up the object right there. So that there. So getting back to that there. So again, you just simply sketch that for each. So there should be 6 drawings. So they can be hand drawn or they can be, and the easiest way is probably to hand draw and take a picture with your phone and upload it to the computer or something like that. Email it to yourself so you can put the picture in your report right there. Or if you're somebody who's really good with computer graphics, that there. So I mean, I've got my pen so I can cheat, but most of you don't have access to a tablet with a pen right there. So I can cheat easily and do it that there, but you're going to have to probably draw on paper and take a picture of it or scan it right there. So, okay. Now, here's the hard part, and I've tried to sit down and determine every step you need to go through in order to pick up the object, and I came up with about 11 moves that you need to go through. That there. Determine how to move to this location without knocking the object over. So you can't immediately just rotate the thing over to where it's at. There, you need to raise it and move it over above it and then come down on it to pick it up. So you need to figure out how to move to that location right there. So that's probably going to be 2 moves. One move to move above it and then another move to move over it. Then you need to open the gripper. Now again, this particular one right here, and I don't think I can draw right there, this first one right here, this is to get in position right there. And that's probably going to require that you move all 6 motors right there. So you're going to have to move all 6 motors in order to get in position right there. And coming up with that position is what's going to take you some time. Right there. Figure probably an hour and a half to do this lab, and I'll talk about when you can do it here in a little bit. Then you open the gripper, rotate the right position, lower it down, and that there, and then close the gripper. And then, as I pointed out last week, do not completely close the gripper. In other words, I think 0 is completely closed, but you'll find that out when you do the first part of the lab. But 0 and 180, I think is completely open. 0, I think, is closed. So you take it to 180, but you'll take it to like 30 or 40, and then you just kind of experiment. You kind of walk in, because if you take it to 180, you're liable to strip out the that there. We just bought these. Please don't destroy the grippers during the first lab, okay? That there. Please don't. In other words, guesstimate. Go in, 100, 80 until you get to just the right amount to where you can pick this up right there. And I suggested the perfume bottle last time, or I think what I do, someone gave me their lip gloss or something. That worked fine. Guys, I'm sorry. Maybe if you play chess, you might have a queen or something that would work that there from a chess set that there. Or I can't think of something that most guys have laying around that would fit in this category. But find something you can pick up. That there, or have one of the ladies as part of your team and steal her lipstick. That there, that there. Lipstick works very well too because it's a small, slender container right there. But any of those kinds of things work. That there. So then you close it. That there, rotate it to the, you rotate the right position, lower it to the object right there. So these are the steps to pick it up actually right there. Then close the gripper, I point that there, raise it, just rotate it a little bit just to show that that you can rotate it, and then just put it back down and then take your arm back up right there. Now putting it back down is a little trickier than it sounds because You can pick it up anywhere on that there, but you have to remember to take it back down to the same place so you don't slam it down too far or you drop it from a half an inch to where it got there. And you may find that tricky because these motors, as I said, are not super accurate. So, you get as close as you can get that there. Open the gripper, move the arm back up, just rotate it out of the way, and you're done. This is going to take you a while because this is all guesstimating how to move this. You're going to spend some time moving the robot. All right, that's a little too far, this is a little too that there. It's going to take you some time. Again, all these steps are done by experimenting with the arm right there. There's this way of doing this mathematically that involves, fifth order, fifth order simultaneous equations and that there, and you know exactly where the zero spot is. We're not doing any of that stuff in this class because I said that math is really beyond where I want to go with this class. Plus, with the repeatability of these robots, it's going to be off anyway. So we're just going to simply go through the steps up there. Okay, once you're done, just take your phone out, just record, moving the arm, picking it up, rotating it, putting it back down, setting it up right there. Because you'll submit that as part of your lab report right there. That there. So all the programs are to be done in MATLAB. And I put the instructions down here on how you would do everything right there. So, right there. The first instructions right there is S is equal to, these 4 instructions here, actually these 3 instructions, then we have a pause to let things happen right there, is that we open S as a serial port, and I said COM4 here. That's what it was when I was in class last Friday or last Tuesday. It was in COM4. I ran the program today and it's moved to COM3 on my computer. So that there. So today when I ran it, I had to move it to change it to COM3 right there. So, and then we open it, we set the baud rate. We set the baud rate, then we open the file right there. That there. And you just do that once at the beginning of your code. The next thing we do, and I keep thinking that I'm in where I can use my touch screen, right there. I can't use my touch screen. Then we use one command to set the speed, right there. So we set our speed to 92, right there. And all we're doing is just writing the number 92 as an unsigned integer to that port. The Arduino processor knows that the first thing it's going to see after the port's open is the speed. Now, we can't change the speed without restarting the program. That was something that they changed when they, the first iteration of the robot, they came, I sent them all back because they didn't work right. And then they went back and rewrote the software. When they rewrote the software, they rewrote the instructions, so their manual is worthless out there because they changed the format. So out there. So this is your equivalent of the manual right there. Is these instructions right there. So we, right there, and then we do the pause one. Now every time we want to move a motor from now on, we don't send it to speed, we don't reopen the port, we just simply send it to move instructions. And the move instructions are, and honestly I think down the road I'm going to write a little M file or MATLAB function that will just simply called move, and we give it a motor number and a location, which is the number of degrees right there, and then the pause. It'd be a 3-line function, but it actually would be easier to remember than this whole instruction, this whole set of 3. But I didn't do that today, and that there, and it's easy enough to write. It's just I have to pass the 2 variables, motor number, and that there, and maybe by Friday I might have that written, or by next week, that there. If as soon as I write it, I'll just simply put it on Facebook, and all you have to do is include it in the same file, the same directory as your program that you write there in MATLAB. Now, I'm not giving you any instructions on MATLAB here, right there. That there. If need be on Friday, I can do that there. So, okay, that there. So you do this for however many moves you need to make. You might be making 15 moves. right there. So these 3 lines are going to be, you move a motor, then you move the next motor. You move a motor, you move the next motor. There's no way of moving 2 motors simultaneously, right there. The way this robot is set up, we cannot move 2 motors at the same time. And that's a limitation of the software and the Arduino that there. So, the people who designed the robot arm for UniKL, when they wrote the software, they did not put that flexibility in there. So, we only can move 1 motor at a time. It's not going to have that smooth reach over and twist and then do all that stuff. We got to do the step by, the real simple 1 motor move at a time. For this level of class, that's probably okay, because if you start writing programs to move 2 motors simultaneously, then the software gets a lot more complicated. And the whole idea here is just to get a feel for how they work, right there. So once we're done with our 15 moves, so these 3 lines right here are repeated for all moves that we have to make, right there. So this particular one moves the base over to location 180 is what, and okay, that there. Well, if I could have kept the projector, I would have kept on going, but now we don't have the projector either. I'm actually about done here at there. So let me just simply, I can still see my computer, I'm on battery power. I'm just going to read the last part to you. This file is on Facebook right there. If you have trouble reading it, I'll copy the actual file for whatever reason I used it right there. Okay, you need to submit a lab report for each person. That's a little different than what I've done in the past. Some of you have read that. I'm expecting each person to write a separate lab report. Now, you can use the same video for all 3 lab reports and the same software for all 3 lab reports. I'm expecting you to work in groups of 3. Now, you do not need me to wait for me to do this lab. The boards are up in the 6th floor in the iCool office area. You'll see them all over the place because we have no place to put them. We bought them. There's no shelves to put them in, so we just stacked them up on desks everywhere. We lost our air conditioner now. Fortunately, this is still recording. Okay, so your lab report is going to start with an introduction, which is simply, and it's combined with the lab objective. You can call it introduction and lab objective. And basically, you got to tell me what your goal is right there. And I already told you your goal right here at the beginning is the goal of this lab is introduced. So let's just reword that. That's your introduction and objective right there. So the next thing that's going to be in your lab report is the equipment used. Each board has got a number on it that says Bluetooth pairing, and it says like 888. The one on my desk says 8888. It's a 4-digit number. It's different for each board, so just tell me which board you have. That way, if you've got problems with the board, we know which board that needs to be repaired. So again, and what version of MATLAB you're using. That's just to get in the habit. Your procedures just kind of outline, this is what I did type thing right there. Then your conclusion. Did you learn anything? Or was this a waste of time or the lab And then F is your 6 drawings and the MATLAB code that you ran that made it work. And then your conclusion, I got the conclusion down twice. You only have to write 1 conclusion right there. So you only have to write 1 conclusion right there. And I'm going to put the conclusion, actually, I think if I do that there, and I guess I can't save it there since I'm logged in this way. So just keep in mind that you only need 1 conclusion right there. So okay, that was basically what my lecture was supposed to be. It's short today, but you're going to spend some time on this lab right there. So again, pick up a board. You can work on it part of it, for an hour or so, or 30 minutes or whatever. Go back home, do whatever, come back, work on it. I suspect you probably will need at least a week and a half to do this. I'm not setting a deadline yet. That there. Friday, I am not going to hold a class, but I'm going to be here. So anybody who wants to work on the lab on Friday while I'm around, that's fine. I'll be here during the 3 to 5 time slot right there. Now, if nobody shows up, and I'm sitting up there at 3:30, 4 o'clock, and I haven't seen anybody, then I'm going to sneak out. So if you're going to show up closer to the 3 o'clock time. That there, or if you plan on showing up at 4 o'clock, then send me a WhatsApp message or something. I think most of you know my WhatsApp number, right? That there. If not, you can send me a Facebook message, and it actually gets run through Messenger on my phone. So that there, we're in the dark. That there, we're completely in the dark. We're winding up. That there. So. That's all I'm going to say for today, because this room is getting warm very fast and we're all in the dark and it's not a comfortable setting up there. Right there. 21 minutes, that's a record for the shortest lecture I've ever did. But it took us 30 minutes to find a room we could go into, and we only got it working for 20 minutes, right? So, all right.